Hi, everybody. So as David said, yeah, my name's Laurence Watson. I'd say an energy data scientist. I've worked in doing sort of tech things, mostly for non-profits for about the past 10 years, with a side of sort of going into Westminster and doing a bit of climate policy, trying to do some startups, that sort of stuff. My company that I co-founded with three other friends that I met at UCL while studying energy systems and data analytics is called Future Energy Associates, and we're a small energy data science consultancy. And today I just want to talk through three different projects that we've worked on in the last year, just to give a bit of a flavor, I guess, of the kind of work that we are doing, and that I think it will increasingly be around as the sort of energy space starts to digitize, and increasingly data science is being brought in to tackle all sorts of different problems. So I'll talk about the sort of domain stuff, like what the problems are and the organizations we've worked with, and also a little bit about the techniques and tools we use. I'm really curious to hear how you all would have approached some of the problems that I'll talk about, how you would have done it differently, and I'll try and share some of the lessons we've learned as well. So let's go to, oh yeah, so that was my intro. Well, just to say a bit more, the organizations I've worked for. I started off, I did a physics degree a long time ago, and then I worked for a non-profit doing carbon markets called Sandbag, and that was about the European emissions trading system, which is a very unsexy but very important piece of sort of climate mechanism that covered 60% of European emissions, and has recently sort of started to work again. There were many years when the carbon price was very low. Now, due to various sort of tweaks and changes to how many permits are given out and how that stuff is decided, the price is now sort of creeping up and shooting up again to sort of 30, 40 euros. And I think we just saw that Biden's team have just come out with a proposal that they're going to price carbon. This is an important thing. I've worked on like stranded assets in the power sector with Carbon Tracker, who are an organization that popularized this idea of the carbon bubble, and that fossil fuel companies' assets won't be worth what they say they will because of climate change, essentially, because we won't be able to burn all of the resources that they say they've got. And then I did quite a few projects around remote sensing, about using satellite data and aerial imagery. If you saw the last talk I did with Data Science Festival, you would have seen me talking about trying to identify and locate solar PV panels using computer vision and aerial imagery. So that's a sort of rapid fire. Who am I? Future Energy Associates, yeah, there's 5 of us now. We believe that combining sort of energy sector domain knowledge with data science methodologies, with machine learning, with analytics, something profit / help address climate change. So hopefully by the end of this talk, you will agree. And certainly like the people we've worked with seem to agree. And not to kick like the energy industry at all, but when you look at people who are building out power infrastructure or things like that, there's lots of sort of mechanical engineering, civil engineering, there's all sorts of other roles, but there aren't necessarily like software teams, there aren't necessarily data scientists. And this is at a point where there's a huge push now to sort of increase data access, to sort of go to presumed open, to publish as much data as possible. And so then once you've got the data, what do you do with it, or how do you manage it in the right way? So we think there's this sort of growing need. And yeah, everyone is sort of starting to get on board, and the world is increasingly taking sort of meaningful action across the board on climate change, affecting all sectors of the economy. And the UK is going to host the Conference of Parties, COP26, in Glasgow this year, where the world's leaders are going to come together, and it'll be the first time. It's a really important conference because in the Paris Climate Agreement, everyone made a bottom-up commitment to a pledge in terms of what they would do in terms of their own country targets. So that they said, right, we'll be 50% reduction by 2050 or whatever at a country level. And at the same time, there was also an agreement of a ratchet mechanism. So they would have to increase it each time. And this is the year where everyone is meant to come back to the table and say, this is how we've increased our ambition. So an important conference. So the first project that I'll talk about is with an org called New Automotive. They're a new non-profit group who want to increase and sort of help the transition to electric vehicles. And the UK has a 2030 ban. So after 2030, no more petrol and diesel sales. They had a plan. What they wanted to do was understand EV sales, but they also wanted to understand how many miles are driven by electric vehicles versus miles by traditional vehicles, because that's really where the emissions come from. That's what really counts. So, and you can look them up at newautomotive.org. So we had two data sets that we wanted to really get to grips with. One was the Department for Transport, which produces loads and loads of really good stats. And UK government data.gov is really good, as I'm sure lots of you know, in terms of publishing, in terms of data quality, in terms of timeliness. So it's all out in this ODS format, which is sort of like tabular data, like an Excel file. So we had these DFT stats about licensing, and then we had another exciting data set. They had managed to get a license key to the DVSA. The DVSA regulates MOTs, so every car has to get an MOT every year to prove that it's roadworthy. Unless it's new, then it doesn't have to get an MOT for 3 years. So we'll come to that, because that tripped us up later. So there's around sort of 35 million vehicles on the road. There's about 10% churn, so 3 million retiring every year and 3 million more coming online. So that added up to about 500 million records. And we could query the API and get a load of JSON files back. I think we had 140,000 JSON files, 500 million records stretching over time. So how would you go about parsing that, or what would you do with it? Keen to hear, and we can discuss later. But what we did was passed it in Python and threw it into BigQuery, Google BigQuery. I don't know if any of you have used BigQuery. I'm sure lots of you have. I was very, very impressed with it. I hadn't had cause to use it before, but it just makes querying large data sets very fast, very easy. Some of the disadvantages, so it's a columnar, don't know if I'm pronouncing that right, data store. So all the columns are stored separately on disk. And so that means, due to the way it's architected, it can be extremely fast, but it's not very good for deleting. For example, it's not like a traditional database where you can go and index a record and delete or change. You can't delete at all. You have to transform a data set and put it into a new table. So once you sort of get your head around that workflow, it starts to make a bit more sense. So we had these 500 million MOT tests, and the key thing here is the odometer. The odometer is the thing in the car that goes around when the wheels go around, that tracks how many miles is driven. And we had our vehicles data as well. So we could start to join that up, to do simple joins to get aggregate statistics about how far different makes and models were traveling per year on average. And there was a bit of a timestamp thing, because obviously the cars don't get MOTs neatly, at the same time period every year. So you have to normalize it against time. And sometimes they fail multiple times. Lots of tricky things to trip us up that we had to work through in the processing. And if you want to, with BigQuery, because it's so fast, if you want to say resample your mileage into long format monthly, so your data set is now 400 gigabytes, why wouldn't you do that? Which we did for some reason. You can still query extremely fast. It does start to become more expensive. BigQuery is a $5 per terabyte query. So querying the whole table here starts to cost a few dollars per query. So I don't necessarily recommend fine detail resampling in BigQuery, but that's something that allows you to do really easily. Amazing tool for big data. So some of the things that we found when you start to plot, like what do these miles look at over time? One, for some reason, they sometimes go from miles to kilometers. So you have to be careful of that. They're not always monotonic, i.e. they're not always going up continuously, increasingly. You can see in this chart that there are some like spikes down and one that goes up and then down again. And there's a few reasons for this. One is that when the people at the garages are entering, they can make a mistake. So maybe they can add an extra 0 and make it 10 times as much, or they can miss out a digit and make it 10 times less, and so on. Or other factors that we just didn't really explain. So there was a processing step where we would detect these sorts of issues and just filter them out. And over a data set that was so large, it wasn't too bad to throw away some of the data as well. So what did we get out of it? This was just the counts. So these are all the vehicles over time. You can see it looks pretty good, sort of back to 2000. And then after that, it's sort of unclear what's in the data set. There's, clearly there were MOTs happening all through the 80s and 90s, but they don't look like they've made it in to the DVSA's digital records through the API. And you can also see when we got it, there was a bit of a lag coming in for 1920. That's because of this new cars issue. The new cars won't be in the MOT data set. But this seemed like a pretty good basis for doing this analysis about combustion engine cars and battery electric. And we also had from the DFT stats about where, like which counties, which postcode areas was the biggest EV sales were happening. So question to everyone, you can just answer yourself or bung it in the chat. I'm not reading the chat, but answer yourselves, where is the highest concentration of EVs? And I'll give you a clue. Well, if I told you the postcode was, I think it's TW6. Does anyone know where that postcode is? So it's not in London. Oh, I can look at the chat. Near to where they're manufactured. Yeah, so that's so it's actually it's Heathrow Airport, because they have bought a load of EVs for their fleet. And so a lot of that stuff at the early days, it is about commercial fleets transferring. That's a big part of it, as well as individuals. But there is also registered keepers as part of the data about cars, which is about who it's licensed to when it's sort of first put onto the road. And there are lots of buildings in port towns that seem to allegedly contain thousands and thousands of vehicles, and that's because when they're imported into the country, they are registered with a company at the port. And so that again can skew your, if you're doing a sort of spatial analysis, that can make things look a bit weird until you start to understand some of those dynamics and filter them out. So this is just a brief little sort of time period of animation of where the fleet, where the EV sales are over time, and I think this is at postcode area. And what we can do now is, so we've got our two data sets, the licensing and the miles traveled. We can look at what makes a popular. We can start to look at the EVs and the cumulative sales of EVs. The Nissan Leaf. I think the Tesla is. So Q3 and Q4 was quite good for Tesla. So I haven't updated this chart. So Tesla is really coming up and up. We can look at data over time. So the top chart shows this very strong sort of growth in the drop off at the end, by the way, is sort of COVID sales, which was naturally a massive decline, and then pick up at the end of last year. But very strong hybrid electric growth, and then increasingly sort of strong pickup of battery electric. And one of the jobs that New Automotive has stressed to us is that they don't really want to sort of endorse hybrid or plug-in hybrid. And that's because the emissions from those types of vehicles compared to battery electric, about 3 times as much. So it's very simple. It's battery electric or not, please, is the message from them. And the data that they want to use to tell that story, is part of this. The lower chart, you can see, so, all of our new battery electric hybrids are just a tiny line now, barely visible, but you can see the rise of diesel, from in the 2000s, and then after Dieselgate and everyone suddenly realizing that, hang on, diesel's actually spewed out loads of emissions, and the whole scandal of VW, cooking the books about how many emissions they're actually pumping out. Diesel sales have dropped off a cliff. So that's a really interesting story, and really interesting for policymakers, really interesting for car manufacturers and all stakeholders. So that's the kind of thing that we were looking to pull out for them. Now, I started this talking about there's this ban coming at 2030, but it's not just about new sales. It's about how long does it take till all vehicles on the road are cleaner. So we might say, so at the end of last year, EV sales were about 10% of all sales and growing very, very fast. But in terms of BEVs on the road, it's still a small fraction. Oh, and just a note on the left, we're a small team of data scientists, and we have to do some data viz time to time. I mean, often. But what works really well, if you have a designer on your team, or you're able to work with the designer, then you know what I mean. It really lifts your work and makes it look 10 times better. And often, the first taste is with the eyes, as the French say. So. First bite is with the eyes. So if you can get a designer to give you a little template to fill in, or some nice SVGs to color in, it really goes a long way. I hope you agree. So designer's called Alice Apsey, who's brilliant. So now we can also start to do some simple forecasts, just take some sort of standard logistic curves, some S curves, and start to sort of look into the future and say, okay, when's this crossover point going to be in terms of new sales? I must say, though, in general, a lot of the stuff I'm going to talk about, we don't end up, unfortunately, doing extremely complicated sort of prediction models, or state of the art, machine learning stuff. I mean, there are projects where we have done applied those kinds of techniques, but a lot of the work in terms of working with energy data is about matching data sets, is about transforming data, is about moving lots of data around. So interested to hear if that's others' experience as well. Here's a battery electric going up. So we think that they've probably crossed the billion-mile threshold now, whereas ICE vehicles are around 270 billion a year. So a long way to go, but coming fast. And there's ICE quarterly miles, so 50 miles a quarter, so a bit more than 50, so 200 and something. And there's the COVID dip, which is DFT published stats around the change in road traffic throughout last year. So we were able to sort of use that and correct what we've done in terms of forecasts. And as I said, yes, so EVs did 1 billion, maybe total. If you just look at petrol Ford vehicles, they did 27 billion miles in 2019. Ford did 55 billion, the most popular manufacturer. So, there's a long way to go, but the rate of change is high. And now, of course, everyone is going EV. I mean, the largest market cap company in the world. If you search top 25 automakers, my market cap, you'll find this open Google Docs spreadsheet, which someone nice has put together and is just open. Tesla topping everything, much bigger than everyone else. Maybe they're overvalued, maybe not, but if you believe that the future is going to be completely electric, they're well positioned. NIO and XPeng are these Chinese EV only automakers as well. But I think Volvo just said, we're going full electric. Everyone's saying once there's a ban in 10 years, of course, it makes perfect sense to say, well, what else are you going to do? Of course, we have to go electric. So that was a bit of a whistle stop. Happy to come back to any of that. But the next project I want to talk about was with a very cool organization called Open Climate Fix. Their tagline is, we use computers to fix climate change. They are very focused around using sort of state-of-the-art, cutting-edge technology, machine learning, deep learning, computer vision. And they want to do it in an open way. They want to do open science. They want to publish everything open source. And you can get involved with them on their website, / get involved. They want to tackle a range of projects, but one of the first ones they've been spending a lot of time on is how they can improve solar power forecasting. So there's around 13.5 gigawatts of solar in the UK grid. The usual demand in the day is, well, it varies, but let's say 20 to 30 to 35, something like that, depending on day of the week or the weekend. So solar can be a big chunk, but of course it's very intermittent. The middle of the summer's day, big amount of solar, winter, not very much at all. But more than that, more than just the seasonal variation, it can be very spiky. And I've put here, what ruins solar power production? Clouds. And that's why it can be very spiky. If you have the southeast of England and there's a few gigawatts of solar all connected up to the grid, shooting in loads of electricity, and then huge loads of clouds come over in a very short space of time, all that is down to zero, and then maybe it's back again. If it's sort of intermittent day, it can be very spiky. And what that means is, if you're national grid and you're trying to balance the grid, you're trying to keep the voltage of the grid stable, or the frequency of the grid stable, sorry, you have to have lots of backup generation already sort of queued up. You have to pay generators, and often increasingly it's sort of batteries and other flexibility, but there's often it's gas, and it's called spinning reserve. So it's generators that are saying, if the solar blinks out because they're covered in clouds, we need you to spin up and cover the gap and maintain the frequency of the grid. So if we can get much better at predicting this solar time series, it'll reduce the need basically for having sort of extra backup on demand, which will reduce the emissions because they won't be there anymore, and it'll reduce the cost. And the reason why this is sort of particularly interesting work is not just because it's sort of really cutting edge, but because solar continues to grow massively worldwide. The International Energy Agency said solar might be the biggest source of world's energy by 2050, which is a pretty big deal. And so techniques and methods of being much better, more accurate at forecasting solar power production could potentially have a really big impact. I mean, the impact that they have calculated they would have is already, you know, significant enough to warrant doing the work in terms of, you know, millions of tons abated and millions of pounds saved. But if you just see solar going up like that, all the better. So clouds are the problem. What's good for tracking clouds? Our old favorite, satellites. And not just any satellite, EU public data weather satellites, which is fantastic. So there's the EU. So we picked up this project from Open Climate Fix. They had done a load of work, a load of the hard work in a load of notebooks, dragging data from an FTP server that EU METSAT rapid scan service had dumped, and then after they'd done that, they then published their API, which we were able to use, so we had an easier time of it. But they had a load of scripts and a load of notebooks, and they said to us, can you please make this more robust? We have a whole list of tasks that we need to get through, but we're too busy doing other things. So can you help us make this all a bit more robust, write it all in, write some microservices or write some libraries to deal with getting this data, transforming it, putting it into the database where we want it to be, write some tests, write documentation, you know, just sort of do all that stuff so that other people can use it as well, and we can move faster on the thing that we actually want to do, which is use the data to predict cloud movements and solar, and then thus predict solar power output. So so we did. So really, really pleased to work with them on this project, and we've developed a library which is quite ropey, but it is getting there, and I'd love any of you to have a look at it. It's called Sativ, Satellite Image Processing. It's quite tightly coupled at the moment to Google Cloud. So if you don't have a Google Cloud account, you might find some aspects of it frustrating when it asks you for your login details, but that's because we use various bits of cloud infrastructure to store data in buckets and transform it and so on. But what it allows you to do is it allows you to download this vast amount. I mean, the data that Open Climate Fix has from EU METSAT is about 2.4 terabytes. So depends how big you think that is. I mean, certainly much bigger than I can fit on my laptop and my external drives. So, you know, and you don't want to use it all at the same time necessarily, but, you know, you want to download it, put it in a cloud bucket, reproject it, because the coordinate system it's in, or the way that the data is shaped, is not the most useful for the UK, for the area that we want to look at. Open Climate Fix has also identified a ZAR as a database tool, a type of database that's really good for sparse data and for time series data. So saving it into ZAR-DB and then getting it back out again when they wanted to analyze it, and being able to sort of slice and dice and say, okay, we want this month in this location. And yeah, there's a nice image of what a reprojected image looks like. I'm just going to break out of my talk now and go into the Jupyter notebooks, though I'm not going to run them, but I am just going to briefly just show you. This is some examples that we wrote to just show how you would do it. So just import the EU METSAT method, load some environment variables. We wrote a download manager, so you could easily just say we want this start date, this end date. You could download the files you need. You could specify a cloud bucket for it to be stored in. Once you've got it, load it, reproject it with some reprojection methods, turn it into an X-array object, and then save that into ZAR. And that enables you to do, it's a good, I guess, a good balance of like flexibility in terms of what kind of analysis you want to do. Yeah, we hoped it was a useful interface. Sorry, I'm skipping quite quickly over this because I think probably this won't make that much sense without spending a bit more time on the library. But here's some nice pictures. Again, these rather beautiful, I think, these satellite images. And in fact, this is sort of what it looks like at the beginning. It sort of starts off us looking at reflectance. It starts off like looking like this, and then when we do these, my colleague Ayrton Bourne did a lot of these like coordinate transforms to basically reshape the satellite data to the ones that I showed you. So you end up with this nice curved grid. That's a bit. There it is. Yeah. So yes, working with Sativ will save 70% of your time working with EU MetSat Rapid Scan, maybe. No, I made that up. But we hope it does save people time. We hope that it is a useful contribution for sort of open science, and other people wanting to do those similar sorts of pipelines will make use of it. And we've been sort of getting in touch with other sort of Earth observation researchers from academia and other places to see if they can actually make use of it, to see if it's going to save them time. And like I said, yeah, if you want to play with it, then yeah, please do. So it's, again, a totally different kind of work, but there were some similarities with the first project that I talked about with New Automotive. And I haven't got slides on this, but I just want to briefly mention that for both of those projects, there was a large component of pipelining. And I'd be interested to know what people think is the best tools for this, but we ended up using Airflow for the satellite data. And we thought, so Airflow is like an open source, it's Apache Airflow, an open source like data orchestration tool. So you can run it on a virtual machine. You can give it tasks, which they call DAGs, which means a directed acyclic graph. So it just can mean an order of jobs. And for us, that was download, reproject, save the metadata, upload to the cloud bucket. But it gives you and you can then give things a schedule. You can make them run on time or in response to a queue or whatever. But it gives you very good like error monitoring, very good visibility on what's happened, where things have failed. You can go back and look through the logs. It's quite robust, but it takes a while to set up. And we thought, given that we've spent some time learning how to use Airflow, we may as well just keep going and try and learn another tool called Dagster, which is a really nice tool to construct these DAGs, to construct these sort of different ways of creating jobs. And it has a GUI interface. And so we ended up writing DAG jobs and putting them inside Airflow, and everything ended up being quite complicated. So I somewhat recommend that, but it really depends on what you're doing. Whereas what we did in the first instance with New Automotive was write a load of sort of much more quick and dirty scripts and run them on a VM and just SSH into them and see how they were doing. And so I can sort of see pros and cons for both of those approaches. I think it depends whether you're building the infrastructure for the long term, like you're building, setting up your sort of data pipelines for your company that are going to have to last for 5 years, or you're doing, as we are often doing, shorter jobs with a time horizon of months to 6 months. So the last project I'll talk about is a hackathon that we managed to win by a company called Zygo. And Zygo are a very cool sort of digital first PPA platform. Okay, so what are PPAs? PPAs are power purchase agreement. So apologies for all the jargon all the way through this talk. A power purchase agreement means that you sign a contract to directly purchase renewable energy from a generator, from a supplier. So that could be from a wind farm, it could be from a solar installation, or something else. It doesn't have to be from renewables. In fact, it can be from anything in terms of buying energy. And the advantage of doing that for buying it is you might get a cheaper price for the long term. You might get a fixed price for 15 years and you say, I'm going to purchase this amount of volume per year. But you won't, if it's from a wind farm, you won't be getting energy all the time. You'll have to buy it from the grid the rest of the time, depending on your needs. And at the moment, these PPAs have been really going up and up. A lot of it has been fueled by data centers from corporates, increasingly buying renewable energy directly. And Zygo is a digital platform to connect up these energy buyers on the one hand and sellers, renewable energy suppliers, well, not suppliers, but generators on the other side. And there's lots of room for innovation. And this was what Zygo's Ecohack was about. It was saying, how can we do an aggregated PPA? And what that means is more than one buyer. You can make it more than one seller as well and make it more complicated. In fact, there's loads of ways you can make this complicated. But for the purposes of this hackathon, the Ecohack, that was the problem statement. And we can talk later what people think about green hackathons and the role of hackathons in data for good as well, because they often crop up and they don't always have the result that people want, which is like a sort of sustaining solution to the problem that actually gets developed. Often it's a sort of one and done thing and people go back to their jobs. But Hey, in this instance, yeah, we have been keeping talking to Zygo about how they might actually implement it, which is great. So brilliant outcome this time. Some of the problems are, it's not just that there's sort of more people to sign the contracts with. The legal stuff gets harder in terms of people's obligations, but people have different demand profiles. Everyone's using energy at different rates and different volumes, and maybe they want to sign a contract for different lengths of time. You know, I want to sign up for 10 years, they want to sign up for 15 years, and maybe also we have different credit ratings. Maybe, you know, I'm very responsible and this company, you know, for whatever reason is more of a risky bet. So how do you combine us in a way that makes sense? Sounds like a data challenge to me. And Zygo supplied a load of data for a load of sort of made up, sort of synthesized, but semi-realistic sites with credit ratings, with desired terms. So the x-axis on this is how long do they want to buy the electricity for. We also have the sort of volumes, and we were able to sort of create synthetic demand profiles depending on what type of company they were from other data that we had, which was useful, because at the start, if you want to group people together, you need to do some sort of clustering, some sort of matching process. And the colors here are credit ratings. So for the purposes of the hackathon, it was, you know, A, good, B, less good, C, the worst. Well, actually, I think, yeah, I think that's right. But it seems also in this chart that the worst credit ratings wanted the shortest amounts of time. So I don't know if that is related in this chart or not. So they sort of set us off. So our solution to this problem, how can we fix aggregate PPAs? How can we allow multiple buyers to come together to all purchase electricity that they would then share out between themselves? And this is I should clarify, this is what's called a virtual PPA. And what that means is it's in contrast to, say, a behind the wire or a private metered PPA. Like, we wouldn't get a wire going from the wind farm straight to the facility. You know, that is possible, but that wasn't what we're talking about here. A virtual just means the renewables generator puts electricity into the grid, and then it goes into the grid, and we take electricity from the grid. And, you know, the sort of ownership and the payment is sorted out via these contracts. So, you know, are the electrons the same ones that are generated coming in? No, that's the sort of virtual element. But that flexibility means it makes it a lot easier. It means, you know, you don't have to be co-located next to the renewable generator, but maybe you're in the same part of the country, for example. So our solution, and we have a little blog about this if you're interested, was pooling the buyers, which of course we sort of can't avoid it, making a dynamic price for each of them, and then that sort of enables this secondary market, because we've sort of we've sort of created this flexibility on top of this contracting layer. Once we've worked out how to dynamically assign risk and therefore price for everyone on the buying side, you can then sort of start to enable more complicated financial things like sort of swaps and like volume risk adjusted mechanisms, which I won't go into too much detail on that, but it was appealing to Zygo, certainly. And that meant, you know, more flexibility, so more access, a bigger market, because smaller buyers and perhaps buyers with worse credit ratings could come in, like smaller businesses, and ultimately, hopefully, reduce risk for the suppliers as well. Because if I'm a wind farm selling to one person and they default, that's bad news for me, though I can always sell it into the market. But if I'm selling to 10 people and one of them defaults, that's not so bad. And, you know, so the risk can be reduced this way as well. So how do we estimate the risk? We did, so the shape of this line, you might see, is sort of similar to the shape if you squashed all of these lines together, and that's what this is. They've sort of been squashed over in terms of total demand per year. And we did a Monte Carlo simulation, estimating how often each the pool would default, or how much of the pool would default over time, and turn that into quantiles. And so then by comparing the sort of no default, like everyone is perfectly well behaved case, to a median simulated case of some riskiness, we can then sort of take that back to the risk of each site. So we now have like a sort of comparable risk metric per site. And that then and once we've got the risk, I won't do the calculation, but we can then turn that into a dynamic price per buyer, which is calculated to do with looking at what the price would have been in the electricity market, plus this credit rating factor. So once we've got this price for everyone, we're now saying, okay, we've established a way where everyone can be in a pool and can buy, but they all have different prices. What we then wanted to set up was this idea with these two slightly complicated slides around a secondary market. So, and that allows us to do things like volume risk arbitrage. And so if we have two sites and one wants to increase their risk and the other one wants to decrease their risk, but they don't want to, sign up new contracts or do anything like that. The way that we've set it up would allow third parties like a bank to come in, purchase the contracts or like take over the contracts directly from the original buyers, and then pay the suppliers the difference, and then do that in one site and another site at the same time and arbitrage off the difference between them. So it's like a credit swap. I'm not sure these diagrams help that much, but if you're familiar with sort of general sort of underwriting and financial swapping, that was what we were trying to get to with this whole concept, that you were going from this sort of very static market of, just one buyer, one seller, to a much more dynamic thing where you could have pools. And ultimately you could have pools on the demand side and the supply side as well. And of course, there's lots of simulation that one could do for this in terms of risk analysis. What else do I want to say on this? Just to finish off on the Zygo idea. Oh yeah, so in some ways, the tranche of buyers, is similar to the like collateralized loan or obligations, and the CDOs that cause the subprime real estate credit crunch. That you're parceling up people with better records and more reliable sort of buying portfolios with sort of weaker ones, and ideally, they're still, well, we would still price them fairly. So hopefully that doesn't mask, underlying riskiness. But that was the idea with that you have these tranches. Okay, so how are we doing for time? Cool. I'll just whiz through. So that's all my examples. I'll just whiz through a couple of other things that I want to mention. I'm getting involved with an organization called Climate Subac. .org, or the Subac. Subac was like a sort of Balinese method of irrigation where communities would share water collaboratively. And the belief at Subac is sort of climate data is sort of like the water that's going to power a huge amount of non-profit, data-driven non-profits. And we see this amazing explosion in climate tech, but there's some things that new startups can't do. And part of that is like regulatory, part of that is policy, part of that is like changing people's hearts and minds. And so we see the non-profit sector as like a really important part of that. So we want to accelerate and bring in a whole sort of a variety of new sort of data-driven non-profits that we're gonna help and amplify, and continue making a difference and pave the way for a lot of the massive changes that we do need to come. So just sort of work hand in hand with the Climate Tech Centre, and to prove to people that you can have a really good, you can have a good status, you can be well rewarded in terms of your salary, you can have a good career path working for nonprofits. And I've spent most of my life working for nonprofits, so I believe that. So check out Climate Subac if that speaks to you, or if you know anyone that it might. A plug for a friend, Dr. Mikhail Nahmadi is starting a new organization called Climate Policy Radar. She created this amazing project at LSE called the Climate Laws Project, which is the biggest global database of climate policy and law, used to sort of support evidence-based sort of decision-making on climate everywhere. And, it's so important in a government. People are always saying we don't want to be first. We don't want to be the first people to do a carbon tax or an electric vehicle ban. And what Mikhail is building, and ultimately it'll be a huge sort of text mining, amazing effort. But you can say, for a start, you can say, well, these people have already done it, those people did it like that, and this was the result. A huge amount of sort of building up the evidence for evidence-based policymaking, as she says. She wants a sort of a bold CTO. So if you know someone who wants to take a leap and has wants to do something really worthwhile, forward that on, please. Do work that matters. I'm sure you all are. Keep doing it. And part of our ethos at Future Energy Sessions as well, and through these projects, is have fun while doing it and do things that are interesting. So I'll leave it there, and yeah, let's have a good discussion in the remaining time.
Perfect. Thanks very much, Laurence. That was fantastic and really interesting. And man, your presentation style is, I just absolutely love it. Actually, it's just carving out this hour to listen to you talk is probably one of the most enjoyable things I've done during my work day in a few weeks. Actually, it's been a busy time for me, so having an hour with you, man, it's been much appreciated. So thank you very much.
Thanks, David. That's kind.
Just super quickly as well, in terms of your colleague or ex-colleague at Climate Policy Radar, please introduce me as well. We'd be happy to help out there, kind of, free of charge or whatever. And I'm sure we'll know some people that we can put her in touch with. So more than happy to help there. In terms of the questions, we've got a couple of questions that have come in, so we'll fire through those. I've got a couple of my own as well, so I might still surprise you there. In terms of the people that are connected, if you've enjoyed the talk as well, please do ping a little message in the chat just to say thank you to Laurence. It's a bit of a funny one when you're doing a webinar. You're never too sure how many people are there or if anyone's actually listening. So yeah, if like me, you've enjoyed it, please do drop a little thank you in there for Laurence. That'll be much appreciated. In terms of the questions, first question that came in was during your first session there, actually, from David. He was talking about data in terms of the electric cars. He was wondering if there was anything similar that you know of in terms of electric motorcycles.
Yeah, so like one of the problems that we had was around dividing vehicles into vehicle type, and often with the government stats, like where they say which vehicle type and what make and model are in different places. So you have to do a whole matching exercise just to join that up. What we did with battery electric vehicles was, unfortunately, like create a data set by hand. So we ended up with like 100 makes and models of cars. So it would be the same thing. I mean, the good thing at the moment is that electric motorcycles, there aren't so many of them. So way to do it at the moment is just to make your own lists and then to filter that out with the DFT licensing statistics. They do release one. They release like 200 different data sets, but I could point you to the ones that have motorcycles carved out in it if you would like.
I remember this from your previous talk, actually. You're the data set king. If you need a data set, there's a chance Laurence knows.
If it's energy and climate related, then that's
top of your head. I like that. I like that. Next question there is from Roberta. Is your Sativ a one-off project, or are you productionizing it in some way, making it commercial and non-profit system for the long term?
Yeah, so the philosophy with Open Climate Fix is definitely like to publish stuff and keep it open source, like, and the licensing reflects that. In terms of like making it not a one-off, it's always like it's served our needs, but we've written it so that we hope it'll serve others in the future. Of course, that doesn't always work with open source, and often, it doesn't, like, maybe no one will use it in the future, and that may happen, but the way we're trying to sort of make that not the case is reaching out to more people, to more professionals, and saying, how can we make it so this does do something for you, and we will try and leave some of our time forwards into the future for maintaining it and making it work. But it's not a commercial problem.
Thank you, mate. Next question, specifically about your beautiful clouds. What algorithm, it's from Alex, what algorithm did you use to detect clouds in those images? Yeah,
so there's a chap called Jack Kelly, who's one of the co-founders of Open Climate Fix, and what he's trying to do is he's trying to use computer vision techniques to do like next frame prediction. So not thinking about like a weather system or a weather model at all, but literally just looking at an image of clouds and trying to get a neural net to predict the next frame, how the clouds are going to evolve, and it's looking quite good. So how do you then turn that into like a cloud map? I think is what you're saying. You've got an image and you want to do clouds. There's a few things you can do, like pixel intensities. I mean, because some of the satellites have different bands, like you can do like a comparison between different bands, and then it's very clear. But there's some sort of pixel-wise way where you turn it into a raster map. You turn it into a map and you say, here's the clouds and here's not. So, but there's machine learning ways. There's like neural net cloud detectors, and then there's also more simple sort of like different band comparison. You can say, if it's more than 99% white on this channel, it's a cloud, and if it's not, then it's not, and that sort of thing.
Okay, thank you very much. We've got 3 more questions, and actually I wasn't expecting it to go this way, but it's kind of around volunteering and finding jobs in this sector and stuff like that. So we'll come to those in 1 second for sure. I think as I was scribbling away, as as you were going there. What other particular areas in climate do you think could really benefit, from data science?
Yeah, I mean, like, there's a huge push from government called like modernizing energy data access, and there's a lot of stuff about smart homes and like home energy consumption, and everyone is sort of very hopeful of the sort of digitizing our homes and electrifying and having, smart turning the heating on and off. And then also once you have an EV and then you have solar panels on the roof, you can sort of dramatically change your consumption profile. And again, it's vast amounts of data. And so the consumer stuff is really interesting because it's very different from what like traditional campaigning and NGOs and non-profit world, they don't really got anything to do with consumer focus apart from membership organizations like Friends of the Earth. But they don't sell products, they don't sell services. So this sort of new intersection of like and then compare that with big tech, which is all about like consumer facing, like massive big data and recommendation. I see those two sort of coming together and being really exciting. And as we start to find out actually dramatically better climate solutions for, like your transport, your home heating, your things that you buy, how you eat, like that's all very, very exciting stuff. A lot of other things is really hardware though. It's hard to get away from, like a lot of climate change is about stuff, tech, it's about different fuels, it's about different boilers or heaters, so there's loads of innovative companies doing stuff around like hardware. So yeah, but they're increasingly trying to find sort of data-driven aspects as well. So all sorts of stuff.
Putting you on the spot then with your futurist hat on, what does the future home look like, do you think, in terms of consuming energy and things like that?
Yeah, it's a great question. Like, I know the sort of energy systems catapult and the various catapults are thinking about this a lot. I think one thing that I think, which maybe not everyone thinks, is that there can't be a one size fits all, because the building stock and like homes are so different. Like in a block of flats, or even in a terraced house, I'm in a ground floor flat in North London. So the front and back of my flat are exposed to the wind and the elements, but the other three sides have other buildings. So it's much more energy efficient than a detached house, in a village or the edge of the town somewhere. So probably we shouldn't have the same technology. We shouldn't have the same heating. So there's all sorts of different things that you can have. There's now like infrared heaters. There's and sorry, in terms of like what it's going to look like, it used to be that you would get all of your home white goods from like the same company, right? You go for British Gas and they would give you the boiler and the oven and everything gas powered. And I think maybe we might see more of that in the future, that it'll come all the way around. And it won't just be that you're buying your electricity from Octopus. You'll also be leasing an electric vehicle or a share of an electric vehicle, right. And you'll be getting like the heating, and you'll be getting something else, and you'll be getting like it'll be service based. It'll be like, your energy use as a service, including like your heating and thermal comfort, and it'll all be wrapped up into one, maybe. But that would be cool.
I love the way you caveat it with a maybe. This is being recorded. We'll come back to you. This will come back.
Years. Yeah.
Man, cool. So we'll jump back to those questions that have come in there. So we'll go to the question from Victoria. Have you done any analysis on the effect of electricity production for EV on the climate change?
So I haven't personally. I know that sometimes this is people are saying, how will the grid deal with like a vast amount of new EVs? I think like the best answer is like broadly, the big picture is that we know how to decarbonize the power sector. We can build loads of renewables and batteries. That's sort of much easier than lots of other parts of the economy. So even though, yes, like more electricity generation has challenges, it's an easier challenge than decarbonizing transport in other ways. And National Grid sort of say they can deal with it. And also having lots of mobile big batteries is useful for the grid in other ways as well. Like that has benefits to a renewable grid. So yeah, some challenges, but like still seems like the most promising option by far.
Thank you. Question there from Alok. This may be a quick yes or no, to be honest, but they're asking, have you tried Blazing SQL for projects like querying DFT data and Prefect for data pipelining?
I've had a look at Prefect, though I haven't tried it out. There seem to be like quite a lot of those kinds of data orchestration tools, and they definitely seem cool. I'd like to check it out at some point. Blazing SQL I've never heard of, but sounds cool. I'll check it out. Thank you.
Yeah, I thought that as well. I know nothing about it, but I'm sold. I'm in on Blazing SQL.
Good name.
Cool.
Okay.
So we'll jump in. By the next few questions, it's very clear actually that there's a lot of interest in this sector. people looking to work in this particular area, either full-time or volunteering and stuff like that. So we'll go to the top question there from Michael. Really interesting. For programmers interested in donating spare hours to open source projects that can have positive impact on climate change, have you got any thoughts on how they can get involved? Is there particular sites and resources that they can go to?
Yeah, so Open Climate Fix has a like get involved page, and they have some opportunities to work on projects. Also, a much bigger community is climateaction.tech, which is really awesome, like a massive community of tech people interested in climate. They have loads of talks, workshops, and discussions. I think they do, if you find through their website, they do have a list of like projects needing help on. So that's probably my best one. There's also, for the other jobs questions, there's another group called Work on Climate, and they have a Slack, and that's a lot about, you know, climate tech startups posting vacancies. But yeah, climateaction.tech, brilliant, and Work on Climate, both really good.
Fantastic. Yeah, you've jumped into the next question there from Alex in terms of permanent jobs that you might be looking for. So I guess that'd be your recommendation there. That's Slack community and following up there.
Yeah, exactly. I mean, I think if you Google like, you know, TechCrunch net zero and like look at, I mean, not everyone wants to work for a small growing startup. You know, it's a bit of a chaotic place a lot, but there is, if that is exciting, then I think, yeah, just Googling companies that have recently raised money and then reaching out to them is not a bad way to go. I definitely recommend the two sites I just mentioned that have very active Slack groups. What else? Nothing. I mean, there is other stuff out there, but I think, you know, one should be choosy, because there's a lot of hype, and I think it's quite easy to be sort of don't believe all the hype, I guess. And lots of companies are saying they're going green and they're going net zero, and even, you know, lots of banks are saying, oh, we're going to be net zero. But I mean, you may have seen Mark Carney has just been criticised for saying Brookfield's, his big investment company that he's now part of, is going to be net zero, and it's going to be net zero because it's invested in loads of renewables. And people said, well, hang on, you're just investing in a massive new coal port. What's that about? And he said, well, you know, because we've got the renewables, so it cancels out the coal. And it's like, and so everyone's saying, no, wrong, you know, that's not how it works. But, you know, so think critically, I guess, you know, when you read companies talking about the action they're taking, is my best
bit of due diligence is what you're suggesting there. Yeah, definitely, sounds good. Next question from Sarah. Again, it's a good one. Actually, no, we'll roll two into one, actually. So we've got a question from Sarah and a question from R. First question from R: how important is it to have energy domain knowledge to be a data analyst in this field, or do you collaborate with other energy experts in the team?
Yeah, I mean, it depends a lot on the task that you're doing and the job that you've done. I mean, I think because we work we have quite a big specialty in energy projects, and so we find that the range of knowledge that we have within the team, and, you know, so one of us has done a lot of work on like the balancing market, one of us has done more on wind, one of us is more of an engineering background. So it's really useful to have that mix, but it's very useful for us to have a broad sense, because a lot of the energy problems are quite related, you know, whether it's from like the cost of energy to the, you know, how this impacts the grid to. So it's useful to have that multidisciplinary stuff. If you're joining an organization, I would say it's less important depending on the role, especially if you're coming in as a techie, as a data scientist, because they're saying we want someone to solve these technical problems. We'll fill you in on the business knowledge you need to have. You know, we just need you to have a really good foundation in stats, in coding, and being able to build your models in terms of being able to build your production systems, whatever. You know, so I would say don't worry too much about it.
Perfect. Thank you very much. And then in terms of the last question, it's from Sarah. It's actually, after a very interesting climate focus, it's not necessarily a climate question, but it's always nice to help everyone out where we can. In terms of Sarah's question, Sarah's recently completed an MSc in data analytics, and was actually looking for some wider tips in terms of finding that first job. Have you got any tips? Can you think back to when you were starting out, Laurence?
Yeah, I mean, the route I took, I'm not sure I could necessarily recommend, which was I did loads of internships, and, you know, I felt like I wanted to explore and try out lots of different things. And I was like fortunate to be able to be in that position, I guess, to take those internships. But I mean, it's not a bad way in if you can. And in fact, like the people I know who have joined a lot of these nonprofit orgs have just like beaten down the door basically and said, look, you know, let me just do 2 weeks with you, you know. And so don't get trapped into, like, I think longer internships can be a bit of a mistake. You don't want to be doing 6 months unless it's like paid, obviously, with like a track to actually being treated as a proper employee and giving a permanent contract. That's what you want. If that's not on the table, then do a month, do 2 months max, because you really just want to get the experience, and then you can talk it up afterwards. You can say, I was on this team, I contributed to this project, that's fine, and then that's how you sell yourself. Yeah, I mean, the route I chose was that I wanted to be values first. Like, I wanted to think about what was important to me and then picked that way. And it was helpful because it narrowed the choice. I wasn't just saying I'll take any data analytics job. I was saying I'm really interested in climate. I'm really interested in these kind of innovators. So then, I can narrow down the list. And once you've got your list of people you're really passionate about, and when I'm hiring people, I want to hear that they're really passionate and they're really keen, and they've chosen the organization I'm at because they share the same values. And so I'd encourage you, anyone looking for a job to do the same. Think about what you think is important, because someone on the other side of the table, if you say, I really want to be here because of these things, that is gonna make a difference when you're coming in as a junior, because they say, well, we can turn that passion into actually being useful.
Yeah. It sets you apart 100%. That makes a lot of sense. And sometimes for the entry level roles, there can be a lot of applicants. So doing things like that shows how passionate you are can be the difference sometimes, can't it? So absolutely fantastic. Just to wrap things up then, I did mention in the chat if people could fire in a thanks, and we've had absolutely loads and loads coming through. So Sian, Emily, Alva, Alex, Kerry, Victoria, Tara, Paul, Mikhail, Sarah, Elizabeth, Indranil, Brian, Donald. The list goes on and on. So thank you all of you guys that fired messages in there to Laurence. It means a lot, and it really does make it worthwhile. And yeah, I'll just wrap things up by saying, obviously, thank you from us. Thanks for kicking off our Data for Good month. We have obviously more talks throughout the month, so those that have registered, hopefully we'll see you at future events. But yeah, just back to today. Thank you very much, Laurence. Always a pleasure to have you, and really appreciate you giving up your time, man. So thank you very much.
Welcome. Thanks, everybody.
Perfect. See you all soon. Bye bye.